Let's do a calculation involving oxidation numbers determined from Lewis dot structures. Here's two molecules. An oxidation reaction occurs, and the question is, what happens to the oxidation number of carbon number 1 that I've listed here in green? Well, in order to do that, we need a Lewis electron dot structure for each molecule. I can draw those here, and I've simplified them a little because we're interested only in this carbon, so I haven't drawn the full Lewis electron dot structure, but the relevant parts around that carbon. Now, to do an oxidation number, I have to assign the electrons based on relative electronegativities. I'm going to assign electrons to this carbon based on electronegativities on the things it's bonded to. This carbon is more electronegative than the hydrogen, so it will get all these electrons. It's less electronegative than this oxygen, so it won't get any of those. It's equally electronegative with this carbon. So to count them up, the carbon gets 2 electrons from that bond. It gets 2 electrons from this bond, being more electronegative than the hydrogen. It gets 1 electron from this bond because it's equally electronegative with this carbon, and it gets none from this bond because oxygen is the more electronegative element. So 2, 4, 5 electrons around carbon in that molecule. Carbon as an atom has 4 electrons around it. This carbon has 1 more than that, so it has an oxidation number of -1. How about this molecule? Again, we'll do the same thing. It'll get 1 electron here because it's equally electronegative with the carbon next to it. And it'll get 2 electrons from that hydrogen because that bond, both electrons will be assigned to the more electronegative carbon. And none in this double bond because those electrons will be assigned to the oxygen. So 1, 2, 3 is the number of electrons here. Normally has 4, so it has 1 fewer for a +1. So what we have is the oxidation number going from -1 to +1, increasing by 2 steps. So the oxidation number changes 2 steps in this oxidation reaction.